In this video, we are going to build out our first concrete player state. To get started, we need to call the state's update method whenever the player is updated. So we will go into the managed update method for our player and call the state's managed update method. Let's also do the same for the managed fixed update method. Now, let's build out the fixed update method for the move state. We want to update the player's velocity in the fixed update function so that the physics system is updated in a consistent manner. To update the velocity, we are going to use the smooth damp function in the math library. This function allows us to smoothly move from one value to another while also applying a damping force to the movement. This will act like friction and give the player a sense of weight or momentum. We will provide 4 arguments to the smooth damp function. The first argument is the current value of the number we're trying to smooth damp. In our case, this will be the player's current velocity in the x direction. The next argument is the target value we are moving towards. In our case, we are going to take the x component of the move vector from the player's input info. This is the horizontal direction the player is pressing, and we will multiply that value by a speed constant. Let's add this player speed constant to our game settings. We can add a space attribute to the class to help organize things in the inspector, and then we'll define a float called runSpeed. Now we'll use this variable to complete the target velocity for the smooth damp. This next argument can be a bit tricky to understand at first. We need to give the smooth damp function a variable that it can use to keep track of what the current damped velocity is. This is because the function is trying to move between our current velocity and our target velocity, but this is going to take more than one frame, so it needs a way to keep track of its progress. We will define a protected float in our player state class that is called VelocityXDamped, so that each child state will have access to this variable. We don't need to set this variable or update it. We simply need to provide the smooth damp function a reference to this variable as its third argument. For our last argument, we will define another new constant in our game settings. This variable will determine how quickly the smooth damp tries to reach its target. If we have a long smooth time, then it will take a long time to move towards the target. If we use a very short smooth time, then it will almost instantly reach its target. This would feel like a very strong damping force. We will call this value ground speed smooth time because we will come back soon and define a different value for when the player is moving through the air. This completes our smooth damp function. The last thing we need to do is apply the new velocity we've just calculated to our player's rigid body using the method we set up in the last video. We can now press play and test out what we've got so far. You should be able to move the player around. This is the very beginning of the move state functionality. Next, we're going to make sure the player faces in the correct direction while moving. Open up the player script again so we can add some more properties and methods related to the orientation of the player. We will add a float property called facing that returns just the x component of the transform's local scale. Next, we will add a vector3 property that returns the full local scale vector. Now, just like we did with the position and velocity, we will define a method to set the player's facing value. This method will take in a single float representing the direction we want the player to face, and then we will update the x component of the transform's local scale using this value, keeping the other components constant. Applying a scale of -1 to the x component will flip the player's sprite so it faces to the left. Applying a value of 1 will simply leave the sprite facing to the right. We're now going to define a function that will check every frame whether the player's facing value needs to be updated. We will check what direction the player is currently facing and then see if its velocity is in the same direction. If the player is not facing the direction they are moving, then we will switch their facing value to match their velocity. There's one small detail we need to address because we are relying on the built-in physics collision system to move our player after we set its velocity. The player will often move a very tiny amount just because a collision is being resolved. We do not want the player's sprite to erratically switch its direction over and over along with these small changes in velocity. So we're going to define a minimum speed value in our settings script, and then only change the player's facing value if they are moving faster than this minimum speed. The last thing we need to do before testing this is to call this update facing method in the update method of the move state. Since this update is related to the animation of the player, we should not perform the call in the fixed update method like we did when changing the velocity. Instead, we will use the update method which is called every frame rather than at a fixed time step. Now, let's go ahead and test this out. Press play and move your player around the stage to make sure that they face the correct direction. Also, double check to make sure you don't get the erratic changes we added the minimum speed to avoid. You might even want to go back later and see what happens if you use 0 instead of the minimum speed for the update facing check. Finally, let's add a method to our player script that will update the animation based on how the player is moving. We are going to need another new constant in our settings to help write this method. We are going to define a minimum run speed. This is for the same kind of reason we added the minimum speed to our facing function. We don't want the player to start their run animation until they are moving at a decent speed. We will check whether the absolute value of the player's velocity is above the minimum run speed, and then play the run animation if this is true. Otherwise, we will put the player into its idle animation. Let's add a call to this update animation method in the update method of the player's state, and then we can test this out. Your player should now face the correct direction and use the correct animation while they run and stand still. In the next video, we will introduce another new state which will add a new action to our player, the duck state.